Hello, everybody, and welcome back to another Cypher podcast, another Cypher interview. Very excited for what we're going to be going over today because we've been seeing lots and lots and lots of hacks happen outside of the smart contract vulnerability space. I know all the auditors who are watching this are just saying, audit, audit, audit. Let's do a smart contract audit. Let's get this audited. Let's smash out all the bugs in the smart contract, which is great. And it's fantastic that we're doing better at that. But at the same time, if you do all this amazing work, make your smart contract super safe, super secure, and then you go to deploy the thing or interact with the thing and you leak a key, you ruin a configuration variable or something like that, all of that work is for nothing. So today we're going to be going over Web3 DevSecOps, SecDevOps, OpsDevSec, whatever you want to call it. Maybe Cairo can shed some light on that. But we're going to be actually talking with Cairo from the OpenZeppelin team. He's been working with their Defender product, which is a tool that allows you to do a lot of this Web3 DevOps stuff. Welcome to the call, Cairo. How are you?
Pretty good. Well, thanks, Patrick, for having me. Just a quick intro. I'm Cairo. I work at OpenZeppelin as a product manager, focusing on Defender and a bit of our contracts library. I've been at OpenZeppelin for a bit over 1 year now. So yeah, super excited for the chat.
All right, cool. Well, I guess just to jump into it, what do we call this? Is it Web3 DevSecOps, SecOps, DevOps? What is it that we're talking about? And then what do we call it?
Yeah, I think we usually refer to kind of this whole process of like DevSecOps, developer security operations. And I think the reason is that we try to, go from the first step of, development up to operations, right? So that, I think that work kind of, fulfills every step, right? I think as you were saying, there's so much resources put into, usually the development phase and the auditing phase, but the operations phase is usually like forgotten about. And it's the longest phase, sometimes perpetual, because you can deploy a protocol, not have any changes on the code, and then it's just about maintaining the protocol. So there's like so many, possible attack vectors of misconfiguration of variables, leak of private keys, malicious governance proposals. That to be honest, I think it's one of the most important, if not the most important phases of, I guess, the DevSecOps process.
So you say we should call it DevSecOps. So
Yeah.
how does that relate to DevOps? Is it just we're putting the sec in there because we're focusing on the security? Is there even a distinction between DevSecOps and DevOps?
Yeah, I think it's pretty much the same thing, but with a stronger focus on security. And the reason is that it depends on the protocol, right? But most protocols are immutable on chain, and the code is open source. So the attack vectors in general are just wider if you compare to traditional, DevOps in Web 2. So I think kind of that's the main reason.
Yeah. It's interesting. So we had Michael Lewin on maybe a month ago. We were talking about what to do in the case of a live exploit. And we were talking a little bit about DevSecOps and what to do. And one of the questions that I had for him was, hey, this is Web3. Your code base is immutable. Who cares about monitoring? If it breaks, so be it. It's not your fault. Nobody owns the code. Woo, it's magic. How do you think about that and combining it with DevSecOps here, right? Like if we understand our code base to be immutable, it's this ungovernance protocol. Like, why do we need this? Why is this still important?
Totally. Yeah, I think this also relates to instant response in general, and why is it a good idea to have instant response? And honestly, I think it falls into what type of attacker is exploiting your protocol, and also how exposed are maybe forks of your protocol, right? So if you're having some type of monitoring on your protocol and you detect if there's like a hack or there's a potential hack based on a contract that is going to attack your protocol, then it's much easier to let other forks know and possibly pause them, right, to save the funds. I think that's one of the main reasons. There's also one other reason that is related to detecting hacks when the contracts are deployed. So usually you have the hacker, and in order to exploit a protocol, they usually deploy a contract on chain, and you already have the logic to exploit your protocol on chain. So you can have like analysis, for example, Forta, which is a company that provides AI monitoring on deployment contracts. they have bots that check the logic, and they can basically provide a score on what is probability that the code from this contract is going to attack another protocol. And the reason is that you deploy the attacker deploys the contract on chain, and then the transaction that actually exploits, it's going to happen a few blocks later. So you have a window of time that if you have pretty fast monitoring, you can sort of front run the attack, right, and actually pause your protocol before having any losses from that contract.
So you're saying one of the big reasons to have this monitoring is to actually help other forks, other projects of the same capacity. I mean, obviously, if you're some type of ownable contract, right? If you have governance functions, you would want to have something like this, right? But I feel like the more classic Web3 developer, if you will, that's classic Web3 developer. That's kind of ridiculous for a number of reasons. But a more classic Web3 developer might say, hey, we're on governance. I don't care. I don't care. It's immutable code. I don't own it. Why would they then care about other protocols who forked them and giving this information out to them? Like, I guess, again, to go back to the classic Web3 developer, if they're saying, hey, like, that's not even my code, like, why do I even care about your code? Like, why is this important?
Totally. Well, I think I can give a concrete example in the case of Balancer, right? Balancer, they have a bunch of forks on different networks. A pretty well-known fork is Beethoven on Phantom and Optimism. And there was an exploit, not an exploit, but a potential vulnerability that can lead to exploits, I think, last year. And the reason that they disclosed the vulnerability to their forks is that the governance DAOs, they have basically partnerships, right? So Balancer has a license on the code, and so you can only use the license if you are an authorized fork, right? And that means that if there is a vulnerability found on the forks or on the main source code, then it's the responsibility of the teams to disclose that. Going to the concrete, I guess traditional or average Web3 developer Web3 protocol, I think the main reason for monitoring is just hoping that the attacker is not really good, in the sense that it deploys the contract, and there's maybe time that you can leverage in order to pause your protocol. But it's at the same time, it's a race between having good security and also how smart are the hackers, right? Because you can hack a protocol in one single transaction instead of multiple transactions. It really depends. But with this type of protocols that are immutable, you don't want to risk it. I think you want to maximize the probability of success and the probability of you passing the contracts. So even if the monitoring doesn't have 100% assurance that it's going to work or to pass the contracts, it's at least good to have them running, right?
Right. So basically, to summarize, there are a couple of reasons, right? Number one, if you have some authorized forks, you want to get the information out to them. Obviously, if you are a DAO or you have some type of ownable functions or some type of governance functions, you want to be able to jump in and possibly intervene if there's something malicious going on. And then obviously, if you have a vested interest in the protocol in any shape or form, it's probably in your best interest to also monitor the protocol. Maybe you didn't write the code base for the protocol, but you have $1 billion locked in some protocol. Okay, well, might be a good idea to make sure nothing nefarious is going on. So
totally
makes a lot of sense.
I can give one example of like that specific case.
Oh,
so
sure.
Last summer in, I think, July 2023, there was the Curve exploits, right? And the cause was the Viper vulnerability. And at the end of the day, the parties that were affected were the LPs of the pools. And there were a bunch of sophisticated LPs that had monitoring enabled on the pools, and they were able to withdraw the liquidity because they detected outflows on the pools that they were supplying. So I mean, even if you're a user, but you have a lot of, or you represent a lot of the TVL of a protocol, it also makes sense to have some type of monitoring.
Yeah, I would imagine as we get traditional finance over to the Web3 world, and you have maybe a hedge fund locking up, billions of client money. They definitely wanted to have some extra due diligence and hey, I don't trust the protocol. I'm going to put some extra monitoring in place and do exactly what you just said there, which happened to Viper. That's that's another perfect example. That makes a lot of sense. So you mentioned something a little bit earlier, and I want to just double click into this. So you said, hey, some of these hackers might deploy their contract, and then a few blocks later, that's when the exploit happens. So obviously, you can deploy and execute in the same transaction, right? So if you deploy the contract, immediately execute it. What are your thoughts around those scenarios? Is there something you can do? Are you just screwed? How does that play into this?
Yeah. Yeah, I mean, like, again, it depends, as you said, on the attacker, right? Last year, with, for example, the Euler exploit, we saw that the attacker wasn't really experienced, and I think they deployed like 3 or 4 contracts, and they even got a couple of transactions that reverted. And what happened is that there were bots that front run the attacks, right? So we did an analysis, and last year, 30% of the exploits were exploited in the same transaction that the contract was exploiting, right? So you have like
30%.
Yeah, it's not a lot.
Wow. So 70% were in another way of pointing this. Just sorry to cut you off here. 70% of hackers are noobs. That's basically what you're saying.
I mean, also like there's some limitations, right? The gas in a block is 30 million, and the contract takes more. Maybe takes 29 million.
Good point.
And usually exploits on lending protocols are pretty expensive because you have to loop, and usually the exploits are around rounding errors, so that's very costly in terms of gas to exploit. So that's one of the reasons. I don't know if the majority are done. Obviously, they are not, because they found vulnerabilities in probably audited code. But it's kind of a race, right?
Right.
In that sense. So I mean, it's better for us in the sense that it's better for them to take as many blocks as possible, because it's easier for us to detect those exploits using monitoring services or Defender or bots.
Yeah. Cool. Makes a lot of sense. So before we actually started recording here, we were talking a little bit online, and we talked a little bit about the ThirdWeb incident, and that in particular, that happened 3 months ago. I think it was early this year, right?
It was on November.
November. Okay.
November.
So November last year. So that happened pretty recently. Can you walk us through kind of how that happened, how monitoring was able to help catch some of the issues? And actually, before we even jump into that, can you just, from a high level, explain what was the issue, what happened during the ThirdWeb event?
Yeah, totally. So, first, I think the main thing is that, OpenZeppelin contracts, we provide multiple standards. We provide NFTs, we provide, security in general, like ownable, access control, and we also provide utility, proxies, multi-call. And the reason is that sometimes it can be dangerous to combine these different standards, right? And that's where essentially this vulnerability came from, that it was a combination of using multi-call and using meta transactions. So we received an alert from ThirdWeb, and ThirdWeb is basically a company that works on providing tools for developers, and so they provide plug and play templates. So if you want to launch your NFT, they basically provide a template for that, and you can have like features. And so what happens is that they combined too many features. They combined multi-call, they combined meta transactions, NFTs, everything in one single contract, and it basically allowed for one specific edge case that basically allowed anyone to impersonate any address. So you had the power of, impersonating as the owner, so you can mint as many tokens as you want. There was like infinite power.
I guess I don't know how technical the details that but from my perspective, I'm like, okay, well, every component is usually pretty self-contained. I mean, having worked with OpenZeppelin contracts a lot myself, would the compiler have caught that? Would like a warning have been tossed? Like how was this able to have slipped by on their end? I mean, obviously, we're not on the team, and we don't want to. This isn't like us like putting blame anywhere. But yeah, I'm curious, like, because from my perspective, every time I worked with OpenZeppelin contracts, anytime there is some type of issue, some type of flag usually gets thrown.
Yeah, I mean, usually, and you can go and see basically our past disclosures. Most disclosures are related to logic and to maybe incorrect logic or stuff like that. But in this case, it was rather honestly like just a dangerous combination of dependencies, right? And the reason is that, so first you have multi-call, right? And so what multi-call allows is that you can make multiple transactions into one. So you can basically approve and transfer in one single transaction using multiple. And so you have basically that one, right? And then you have meta transactions. So meta transactions allows relayers or third parties to sponsor transactions for you. So if you're a user and you want to mint a token, you can basically have someone else pay the gas for you. And that means that that person is going to send the transaction for you on chain, right? Now, in that case, because a third party is sending the transaction, the from parameter in the transaction is not going to be your address. It's just going to be them. So they have to find a way of inserting your address at the end of basically the call data, right? And so, yeah, that's basically how meta transactions work. And the issue was that multi-call was basically accepting any call data, and it wasn't checking if that call data is coming from a meta transaction relayer. So what you can do is that you can basically tell the meta transaction relayer, hey, this is my address, but you can pass any address. You can just pass the owner address. And the relayer is just gonna say like, okay, I don't really have to check for that because the contract is going to check for that. So the relayer, they forward the call data, which is poisoned by the hacker, and the contract is just going to say, okay, this is coming from a relayer. We trust the relayer because the relayer only accepts, the user's address, but not in reality.
So so were the OpenZeppelin contracts updated so that was kind of the default? Was that one of the fixes the OpenZeppelin team made?
Yeah, the fix was I think it was like one simple one-line fix. It was just just checking that the user address is in the call data is correct.
Right.
Basically, like stop assuming that the data from the relayer is safe.
I see. Okay. So we had this bug. Mm-hmm. It was in a bunch of ThirdWeb contracts. They contacted you. Then what happened?
Yeah, so they contacted our team, and I remember this was a weekend, so we didn't have a lot of team.
It always is. Of course.
Bad timing. Yeah. And so we already noticed, because we saw it on Twitter, that ThirdWeb, they released a website where you can check if you used a vulnerable contract. So we already were like, okay, something happened with ThirdWeb, but we really were sure if we were vulnerable, right? So a couple of days, I think 1 or 2 days, we actually received a message from them telling that, hey, this combination of standards is dangerous, and we were using OpenZeppelin code, so you guys may be interested. And so then it just started the race, because we started seeing exploits happening. One example was there was a liquidity pool, a Uniswap liquidity pool that was drained, so 100K was lost. That was, I think, the first exploit. So at that point, the information was public, so anyone could notice what the exploit was. And to be honest, the exploit wasn't really hard, and it wasn't protocol specific. So you can essentially grab this exploit and apply it to other vulnerable contracts pretty easily. And they don't have to be forks. You can have a DeFi protocol and an NFT have the same vulnerability. It's pretty interesting. I think we don't often see this type of vulnerabilities, which are working across different types of protocol. And so yeah, we basically were racing against hackers, right? And the main challenge: how can we look for contracts that combine these two standards? In the case of ThirdWeb, it's really easy because they have factories, and the factory is on chain, so you can just see the events. You can see how many contracts were deployed through the factory. But there were so many other contracts that maybe they weren't not deployed with ThirdWeb. Maybe they just combined these two standards. Yeah, and so we needed to look for those. And so that's kind of the main challenge.
Gotcha. So ThirdWeb reaches out to you, says, hey, this was an issue with a specific combination of OpenZeppelin contracts. Panic. You start looking for affected contracts, start trying to get in touch with key stakeholders to tell them, hey, you need to fix this. Not exactly how you were anticipating your weekend was going to go, I'm sure. So you mentioned too. So you said Defender was able to play a big part in actually this active exploit. So how did Defender help you defend against these fine contracts, or how did Defender play in?
Yeah, so we kind of took two main paths, and the main path was just simply looking for bytecode or verified contracts that match the bytecode that was dangerous. So we kind of did like some calculations. We combined the two standards, and we noticed that if you look for specific stuff on the bytecode or in the source code, you can have a pretty good accuracy if the contract is vulnerable or not. The problem with that is that most contracts today, they don't have the security contact in the aspect. So we cannot get in touch with them and tell them, that the contract is vulnerable. So we realized, what if we modify Defender so that you can basically upload your source code and it's going to tell you if you're vulnerable or not. And so we kind of made like what ThirdWeb already did, but more of a superset. Not only supporting ThirdWeb contracts, but also any type of contract that has any type of Solidity version. And so we basically released Code Inspector, and Code Inspector basically gets the code from your contract, runs our checks just to make sure that if you combine both standards, and it's going to let you know in case you're vulnerable. It's going to tell you, and it's going to recommend you get in touch with us so that we can help. And so I think we had more than 4,000 users use the Defender Code Inspector, I think, in the first few hours, which is a lot. And I think more than 10K contracts were analyzed in in a couple of hours.
So the Code Inspector, it allows you to inspect your own code, upload it to Defender, or does it allow you to do a search on all contracts, or how did that work?
That's a good question. That's an amazing question, because it allows anyone to upload any source code. So even if you don't have a protocol, you can grab the code of from any protocol and upload it. So that was pretty dangerous, right? Because at the same time, hackers could use this for searching vulnerable contracts. So what we did is that we didn't let users upload the source code directly. They had to log in with GitHub, and they had to select the repos that have the source code. It's not really a fix, because the hackers could create their own repos, but it kind of prevented, I think, dangerous activities or whatever.
Got it. Okay, so basically somebody logs into Defender, grab their repo, Defender automatically does a quick scan and says, hey, this is affected, do something, or nope, you're good, go enjoy your weekend.
Exactly.
Got it. Okay, makes a lot of sense. So we've seen a couple different strategies for something like this. Like, I know for the Viper attack, like Dune Analytics was used a lot to basically search for specific strings of bytecode where hey, all right, cool, this has this string of bytecode represents a certain Viper version, a certain Viper contract that has the reentrancy vulnerability. Use something like Dune Analytics. Is that it would be cool. Maybe this is you said you're a product manager, right? Maybe this is a product idea. It would be cool if you could do a search, have it grab the code, pull it in Defender, and automatically check all vulnerable contracts immediately. That would be pretty cool. Also really powerful, obviously, if there was a live exploit, and then that was there.
Totally. We expanded Code Inspector to basically support all previous OpenZeppelin contracts vulnerabilities. So if you're using, let's say, version 4, which may be vulnerable to, let's say, I don't know, a random library vulnerability, you're going to get a notice. I think in this case, and the Viper example is a really good one, because the Viper compiler, it adds the version at the end of the bytecode, so it's pretty easy to look for vulnerable contracts. But in this case, it's a bit harder, because you can combine two dependencies, but you also have the optimizer, and the optimizer it's like a black box. It basically modifies the bytecode, in the kind of the most optimized way, but you don't really have a fixed bytecode string that you can look for. So that was also one of the challenges, when doing analysis and manual analysis on contracts.
If someone did optimizer runs 200 versus 1,000 versus
exactly. Every time that you increase or decrease the runs, it produces a completely different bytecode. So
makes a lot of sense. Cool. So Defender basically can help spot stuff right in your code base. So Defender, I know V2 was released somewhat recently. So Defender 2 allows you to monitor for custom transactions on your protocol, and then ping your phone, ping your Slack. What does the monitoring of Defender look like?
Yeah, so monitoring, it basically allows you to get alerts on any type of on-chain activity. You can filter by the function selector. You can even filter by the parameters. So imagine there's a swap function. you can get alerts if someone is trying to swap more than 1,000 tokens. So you have a lot of granularity of basically alerting that you can do. And then you can also basically have filters on the transaction itself, not only the call data, but for example, the block number, the timestamp, the gas, everything, everything that is on chain, you can have filters on that basically. And you can get alerts on, I think we support more than 6 platforms. I know that there's some teams that, if there's a critical alert, they even get a call on WhatsApp and on Telegram. That's pretty interesting. So there's kind of like a lot of flexibility on not only on what you want to monitor, but also how you want to get the alerts.
Gotcha. Okay, cool. So we're getting into the Web3 DevSecOps a little bit. So for these people who are answering these calls, who should they be and who are they? Are these Solidity experts? Are these scripting experts? Who are the main people that you see that are the ones receiving these alerts? What is the pipeline for them or the playbook for them? What should the playbook be? How do we train these people? Yeah, what is the playbook for them? Who are these people? What are they good at?
Yeah, well, usually what we see is that the developers themselves first analyze the alerts, and I think the first step is trying to determine if the alert is a false positive or not, and based on that, if it is an actual hack, then you have to kind of like check exactly the exploit, what is affected, what can you save. So I think there's like 2 main paths. If it's a false positive, then you can offload this to the scripting team or the DevOps team so that they can improve the monitor. But if it's an actual exploit, then it's more on the developer side. But it also depends on the team. There's like big protocols or like big DAOs. They have usually their own security team, so they have their own security researchers, and the developers, they work with the security researchers on trying to figure out the exploit. But that's kind of the 2 main possible paths that we usually see.
Got it. Okay, makes a lot of sense. So I want to go down this. I want to switch gears a little bit here. I want to go down this Web3 DevSecOps a little bit more and talk about deployments or working with private key management, because we've seen, lots of attacks recently where, hey, nothing wrong with the smart contract. Well, other than the fact that it was ownable by like a single EOA, I would argue that that's a big issue. That should never happen. But private key was leaked, protocol got access. How do you look at that and defending against that? What are the tools that you see, or what are the tools that you recommend for protocols that, they have an ownable contract, maybe they have a DAO, maybe there's some risk parameters they need to adjust, maybe they're on a multi-sig. How do you go about working with that private key management? How does Defender help there, or what are your thoughts there?
Yeah, I think like I see this as having different levels of security, right? In the most basic way, like once you have like some type of roles or ownable dependencies in your contract, you have like 3 main levels. You have the EOA level, which is the weakest, right? Because you only have one single point of failure. The private key gets leaked, and usually developers, they share the private key so that they can deploy using the same address or do maintenance with the same address. So I know teams that they were sharing private keys in plain text, and at the same time, I think now lately Foundry is putting a lot of effort into stop using private keys in the environment variables, but instead have them in basically like encrypted in like wallets, right? So I think like that's the first level of security. Then you have the second level of security, which is usually safe or a multi-sig. And that's kind of the same thing as the UA, but with more, with more requirements, because now you have to maybe hack 3 or 4 private keys. And then the third, and I think the most secure option, is just having a governance contract. And I don't think to be honest, I don't know any specific exploits that happened because there was a vulnerability in a governance contract. It's usually that there was a malicious proposal that was, approved by the DAO, but it wasn't in the actual governance code per se. So I think those are the main levels, and it kind of depends on that.
So it almost sounds like easy recommendation for every single protocol that has some type of ownable function is it needs to be owned by some type of governor or at the very least a multi-sig.
Totally. And I was reading like Zach, he published a report on Lazarus, right? The North Korean hacking group.
Yep.
And what I noticed is that they're targeting the private keys directly. They're not, I don't think they're longer looking for bugs in code. They're just trying to like do social engineering through emails, through Telegram PDFs, through interviews. So like now the kind of the approach is more of a social engineering approach and trying to get the private key of the deployer of the multisigs. And it's honestly like they're having success. Like there are so many different protocols that even if they have multisigs, maybe like a 3 out of 6, and they still get exploited by social engineering. So in that sense, it's also a positive aspect of governance and DAOs that you cannot really do social engineering because you have to manipulate like a community, and it's really hard to do that.
It's hard to socially engineer an entire community. It's much easier to socially engineer 1 or 2 people. Okay, makes a lot of sense. So, because I was thinking, hey, we probably should just get better at our private key management. I mean, well, we should do that anyways, but you're saying, yeah, we should do that, but probably more importantly is just have a ton of private keys, be the signers. Boom. Like you don't even have to care that much.
Yeah. And I think also like the path is just going to go towards the smart account path, with account abstraction, where you don't longer have the keys. You just have a contract that you use, like a safe contract or the equivalent of account abstraction, and you just use that, and you no longer have private keys. You just have bundlers and forwarders that send the transactions on chain for you, basically.
Yeah, I'm also very excited for the future of account abstraction with its regard to security too. So makes a lot of sense. Cool. So a lot of things for us to think about as far as Web3 DevSecOps goes. Should there be a role in DAOs dedicated to like writing scripts, doing monitoring, answering stuff? Should every DAO have some type of role like this?
Totally, 100%. I think that it should be like a minimum or a requirement. And the reason is that most stakeholders are probably non-technical, right? So you have to basically prepare everything for them, like a report or like a summary of what the transaction is going to do. And I think reputation also plays a big role here, in the sense that the DAO shouldn't even consider proposals from new people, right? Like very low reputation people.
Right.
And that was kind of what happened with Tornado Cash. That the DAO just voted on a proposal that was made by a new stakeholder, basically. So I think it's critical to have a security team, but at the same time, small DAOs, they don't have a lot of funding or they don't have a lot of money in the treasury to pay for that. So what I recommend usually is that the developers itself, they would have to, check the proposals, at least in the beginning.
So for those who don't know, you want to give them a quick refresher on what happened with Tornado Cash?
Yeah. So there was an exploit on the Tornado Cash DAO, I think last year. Also, it was around June, May. And basically, the exploit was that there was a user that made a proposal to, I think, update a parameter or a pretty small fix. And what they did is that they deleted the contract that was a proposal, and then they deployed a new one, and the new one was malicious. And so the DAO, the stakeholders, they didn't realize the new contract. I think it was using like a metamorphosis contract.
Metamorphic upgrade, yeah. For anybody who's watched Cypher and Updraft, we talk about metamorphic contracts in the upgrade section, so you can learn more about it there.
Exactly, and that was kind of the issue, right? The stakeholders at the DAO voters, they didn't realize the new upgrade or the new contract, so they just voted blindly and passed the proposal that was malicious. And I think the hacker ended up stealing the whole treasury or something like that.
Should kind of a more futuristic, controversial question here. Should you vote if you're not technical? Should you, if you're like, hey, I can't read this, I have no idea what this says, should you excuse yourself from voting?
I don't think so. I think like the DAO or the founding team should be responsible in providing whatever data the stakeholders need to make a good decision. I think that would be it. I think it also depends on the proposal, right? Because you also have, for example, Gauntlet. They do, economic analysis on proposals. So if you are someone that you don't really know about what parameters are changing, it's better to not vote on the proposal, right? I mean, you don't want to vote yes or no without knowing what that proposal is going to do. And I think the same applies for technical or protocol related proposals. But I do think that the founding team or the main DAO group should provide a report or an audit. Like for example, with Compound, we provide audits on every proposal, and the audits are pretty easy to understand in the sense that they're targeted for non-technical stakeholders.
We're almost getting a little bit philosophical here, right? We're almost like politics in a way is a security vulnerability somehow, right? We're like, hey, like the core team needs to go do all that due diligence to give to the stakeholders so they can vote with information. In a sense, we're almost saying if they don't do that, that's, in a sense, a security vulnerability.
Exactly. Like it's like a chicken and egg problem, right? Because at the end of the day, you are trusting the founding team or the main DAO team or the auditor company to provide, a good analysis or good data. So it's a hard challenge. So.
Well, and this just kind of goes back to this whole topic is Web3 DevSecOps. That was the term that we're following on, DevSecOps, right? This person who's saying, hey, cool, contract is deployed, yet guess what? Now that it's live, there's really more things that can go wrong, not less. And we should watch out for those. So makes a lot of sense to me. Yeah, the Tornado Cash one in particular was crazy to me. That's one too where I feel like it's so much trickier too, because right, like the Tornado Cash is supposed to be this ungovernance forum, right? So what do we do? What do we do here? Hey, like it's nobody's job. There's no team. This is ungoverned, or I guess they had the torn token, right? So that's the governance. What do we do there?
Right. Exactly.
Who was supposed to give the information?
Right. Exactly. And I think also one big problem with the DAOs is that it really depends on the token security, right? And I think this comes down to pretty related to Eigenlayer in the sense of like what is the economic security of your project, right? Because if you know that the price of the Tornado token, it's maybe like 0.001, then you can definitely buy a lot of Tornado tokens and just pass the quorum, which maybe it's like 51%, and pass a proposal.
Right.
So it's like a combination. If the token has, or if the product has a high economic security, then the responsibility is in the stakeholders. But if the protocol has pretty low economic security, then anyone can buy the tokens and do whatever with the protocol, right?
You mentioned Gauntlet, right? And there's a couple protocols, or there's a couple of companies doing stuff like what they're doing. Gauntlet, Chaos Labs, I think is another one.
Yeah.
Where they do basically risk audits almost, or like economic analysis. Hey, if you tweak the borrow or the loan to value or the loan to collateral ratio by this much, here's the risk that you take on, blah, blah, blah. It almost sounds like this Web3 this Web3 DevSecOps role is in some sense responsible for that as well. There's all these additional security things, right? So we just talked about, hey, what if your private key gets leaked? Hey, what if there's a bug in a smart contract and there's an active exploit? Hey, what do you do if your DAO upgrade is wrong? Hey, what do you do if you have low economic security? There's all this extra stuff. There's all this stuff that this person is responsible for. It almost sounds like at this point it's like too much, right? I want to ask more about kind of these risk profiles, what your thoughts are there. I want to ask you about Eigenlayer as well, but why don't we as an industry focus on this more, right? It sounds like there's this huge attack vector on the operations side, the DevSecOps, and we focus so much on like, okay, smart contract audit. Why are we not hearing more about the monitoring, about the cool things people are monitoring and the cool scripts? Like, why aren't we focusing more on that?
Totally. I think what happens is that once a protocol launches a DAO or launches governance, the responsibility shifts and it's now divided, right? So when you have a governance, usually the stakeholders, they assume that, oh, another stakeholder is going to care about monitoring, so I shouldn't care about monitoring. Like another person is going to do it for me. And so that creates like a chain effect where, people, they think that, someone in the governance or in the DAO is going to do the monitoring, but at the end, no one does the monitoring, right? And if you compare that to like a protocol that doesn't have a governance or doesn't have a DAO, you have the team that relies on each other to actually care about the protocol. But I feel like once a protocol is decentralized, then the responsibility kind of shifts, and there's not really. Sometimes happens that there's not assigned persons or an assigned team to actually do the monitoring. I think like one really good example of like a team that does development and security really well is Aave. So you have the development team that they're working on Aave before and the Aave blockchain and whatever, and then you also have the security team, right? That usually it's external audit companies, and then you also have the stakeholders, but the stakeholders are just token holders. They're not part of the development team usually. So you have that kind of shared responsibility and divided different groups, which I think like helps make it clear who is going to be in charge of monitoring. But I do agree that I think there's like so much importance in post-deployment operations that need more attention or more resources in general.
We're just not giving it the love that it needs. So you mentioned two things, and I want to kind of go down them real quick. A lot of these risk assessment plans, profiles, when should a protocol start thinking about maybe doing an economic risk portfolio? And you mentioned one such scenario that I think a lot of DAOs don't even think about at all is like, hey, like if your token costs 7 cents and the market cap is, if the market cap is $1,000, really somebody could just come in, buy up all the tokens, and boom, exploit your protocol.
Exactly.
When should somebody start thinking about this? How should somebody start thinking about this? How to approach that?
Yeah, well, I think in this case, when you want to consider the economic security of the protocol, I think the formula is like if the TVL of the protocol is equal or larger than the market cap, then sorry, if the TVL is larger or equal to the market cap, then you're probably going to get attacked, or someone's going to try to buy the tokens, right? Because they can drain the TVL, and the TVL is larger than the cost of buying the tokens, right?
Right.
And then the actual, I think, risk analysis, I think it's something that has to be done every time you want to change parameters. Like every time you want to create a new market, there has to be an economic analysis on the incentives and also the loan, the loan ratio and everything like that. And the reason is that sometimes vulnerabilities can happen not because the logic of the code, but because of the parameters of the protocol. And the reason is that you can have wrong parameters, and that can lead to wrong liquidations. And so then the protocol is going to have bad debt. So there's kind of like there's kind of two main aspects, I think, of like security. You have the logic of the code and making sure that the contract does what it should be doing. And then you have the parameters, right? And if like a lot of people say like, okay, code is law, right? Because it was maybe the parameters were wrong. So I just used the protocol and somehow I made money. Like the contract did what it was supposed to do. And so the fault is on those parameters, right? So I think there's kind of like too many parts of that, security. You can have, the logic and then the parameters. And I think you should be doing security audits on your code and an economic security analysis on your parameters.
Got it. Makes sense. So you mentioned the eigenlayer token, right? So that's very topical right now. So how do you think that they're doing? I don't know if this is too charged of a question. Is it something that you're giving thought to right now? Like why did we bring that up?
Yeah, so I think we connected to eigenlayer in the sense of like shared economic security. And with protocols, if you're using eigenlayer, you're essentially leveraging the security of Ethereum, which is pretty good if your protocol is small, right? Because once you leverage the security of Ethereum, you don't longer have to worry about the token being super cheap, about your market cap. You can just use the Ethereum security and you're going to be fine. But at the same time, it's a challenge because you're not going to accrue value, right? Because you don't have a token. So it's harder for the protocol to accrue value and for the market cap to grow. So it has like its own trade-offs. I think eigenlayer is pretty interesting, and I really like the research behind it. But it depends on the protocol use case.
Right.
Makes a lot of sense.
Cool. So I guess really the last thing I wanted to kind of talk to you about here was another thing that we talked a little bit about before we started filming here was Relayer. So what's a Relayer? How does that work? How does that help developers here? Yeah, what is a Relayer?
Yeah.
Or I guess
So
in the context of OpenZeppelin,
yeah,
what is a Relayer?
yeah. I think it depends on the context. I think there's like some definitions more at the transaction level, but in this case, we refer to relayers as Defender relayers. And relayers in this case are EOAs. So you have a private key, but the private key is always encrypted and it's only used to sign transactions. But the computer that is signing the transaction doesn't access the private key. So the private key and the signing is happening in a trusted execution environment in an enclave. So no one really sees the private key, right? And so that's basically relayers, right? And so how they work is that you can generate keys to access that private key, and you can manage how many, for example, how many uses can those key get. So if, for example, you can create a key for one action. So when you want to deploy your contract, so that's going to be one transaction. So you can create a temporary key that only works with one signing transaction, right? So you can have a lot of granularity on, how many keys you want to create for a private key. And also you're no longer using the private key itself, you're using keys. So you can always deactivate keys, like the API keys, versus if you are using private keys, if the private key gets leaked, that private key is going to work forever. Like it doesn't have an expiration.
Right. So anybody who's taken the Cypher and Updraft curriculum knows I spent probably like 25 minutes in Updraft saying, hey, every tutorial out there is going to tell you to stick your plain text private key in a .env. Do not do that with real money because you're at risk of exposing it. So this relayer, this Defender's relayer, is basically a way to totally circumvent that anyways. You put your private key, you encrypt your private key. Are you actually, so here's what's a little bit scary to me. Do you have to stick your private key into the OpenZeppelin UI to encrypt it?
No, you can. We don't accept external keys. All of the keys are generated in a trusted execution. So we don't know the key, and you don't know the key either. That's basically how it works.
Cool. Makes a lot of sense. So this key is created in a private enclave. Can I hook my Foundry, my hard hat, etc. deployment up to this API key and deploy through that? Because I think that would be another thing that would be really, really helpful. Kind of similar to ThirdWeb has ThirdWeb deploy, maybe something like that. So can I hook my Foundry instance up to that?
Yeah, you definitely can. So we always supported hard hat, but 1 month ago we launched the support for Foundry.
Oh,
so now you can use scripts on Foundry, and you can deploy through Defender using the relayer, and it's like seamless. It's like the same experience as using a private key in an environment variable. Maybe it takes a second more because it's not local; it has to go to an API, but it doesn't really feels different.
So for those of you who are watching this who are a little bit nervous about dealing with encrypted private keys and who have watched Updraft and watched me say, all right, we're going to do cast wallet import. It's going to be encrypted locally, blah, blah, and who don't really want to have to deal with any of that. Boom. Maybe this is a solution for you to check out. Very, very cool. Well,
I just wanted to say that.
Yeah, go for it.
Like one thing that we also tried always doing with Defender is that you get benefits from other features in Defender. So if you are, for example, deploying through Defender, we're going to do checks on your collision, like storage collisions, because if you have an upgrade and you somehow move the storage, that could lead to breaking the contract, breaking the proxy. So we kind of took that idea, right? How can we maximize the amount of benefits that users can get from using relayers and deploying with the relayers? So that was kind of that idea.
Makes a lot of sense. So just, a lot of phenomenal tools in OpenZeppelin Defender so that once you deploy, you're secure, right? Because your security doesn't start and end at the audit. It should start way, way, way before the audit happened, and it should continue way, way, way after your protocol is deployed. So,
exactly.
Caro, that's pretty much most of our questions. I guess, do you have anything else you want to say to the developers, security researchers out there about OpenZeppelin Defender, other hacks, anything like that?
Well, I mean, nothing specific. I think honestly, it's sometimes hard to keep up with the latest tooling and with the latest updates. I think you especially do a great job on showing how to use Cast Wallet and how to connect to Foundry and kind of these super new features. that I think like it's super important to stay up to date with kind of like new releases and new Foundry, features or new Defender features, because at the end of the day, I think, we're trying to put, so many resources into making the developer experience easier that, we can enjoy, seeing developers have success in terms of deploying the contract and maximizing for security.
Definitely. 100% agreed. So stay up to date, y'all. Tools are getting better and better. Web3 DevSecOps is getting better and better, and got to keep using the best tools. All right. Well, Cairo, this was phenomenal. I feel like I learned a lot. I feel like everyone who was watching definitely learned a lot. Thank you so much for joining us, and have a great rest of your day.
Yeah, perfect. All right. Thank you, Patrick.
Thank
Bye.
you. Bye.